Hello, YouTubers. Welcome to my show, Science Thursday. In today's episode, we're going to discuss a topic of water jet cutter overview. So let's dive right into it. Well, first we have to understand water power. Now, why do we want to use water as a cutting material? Well, simply put, it's everywhere. Basically, everywhere there is human, there is water, or otherwise human wouldn't be there. So, water in terms of abundance, it's already there. It's not like argon or like oxygen or something like that. It's very easily, readily available. On top of that, it is very powerful in its natural state, so to say. Like you can see, like it can erode mountains, roads, a whole village, a whole town, or even a city if it wants to. So you have to understand water is very powerful. Now if you take that water and you pressurize it, then it becomes deadly. Now to give you a context of that, like as early as 1800s, humans used water in high places, aka like a pond on top or a lake on mountain tops, drain water from that like around 100-meter below or 200-meter below, and that water was so high pressure, so powerful that it was used to grind mountains away basically. And like that was the early forms of mining. So you can understand the water is very powerful if under pressure. So we utilize that to do our work. So how does this quote unquote water jet cutter works? Well, we take water and we pressurize it. Now generally we measure psi, pressure in psi. So in this scenario, psi can go as low as 600, as high as to 40,000, to even 60,000 to 90,000 psi. It's ludicrous basically. So we put water under tremendous pressure. Now on top of that, water in itself is very powerful at that state. However, it will not be a very effective cutting tool against very strong material. Like let's say you want to cut against marble, granite, steel, titanium, things of that nature. Yeah, they will still pose a threat. To turbocharge water's cutting ability, we add what we call abrasive, basically a quote unquote sand. So we add that. Now again, it's not a sand, it's not a silicon based. Generally they are some sort of stone based. So we add aggressive and then we get more cutting power. Now once you have high pressure water mixed with this, it can cut through almost anything known to man basically, which includes diamond also. So then the question becomes, how the heck you channel such kind of power if it is that powerful? Well, we take the water, we pressurize it. Now we do not pressurize it to ludicrous level right there. So what we do is like bring it to your cutting piece basically, wherever you want to do the cutting, and we constrict it, like we force it through a nozzle, same as a rocket engine. Now this nozzle is made out of generally ruby or diamond. Now you have to pay attention to this one part. So far the water is just pure, it's basically distilled water if you can use it, or filtered water. So does not have the same amount of grinding power. Benefit of that, this will last time. The moment it becomes a jet, now it has the cutting force and all that, we add sand after that. We add the abrasive there. Now moment we add it, the combination goes out. Now you have to understand that this, even though it's like it's a dealing with like quote unquote calmer waters, it still erodes over time. Even this part you have to change. Everything here is non-consumable, but this is a consumable. You have to change it every depending on quality and material grade and all that. They will be like, yeah, every 40,000 hour you have to change it, or every 40 hours. So we have the water, turbocharge it using this, and then we add basically aggregate to turbocharge it, its cutting power. And what can it cut? That depends on the geometry, design and pressure levels and all that, but TLDR would be anything as long as you have enough power. So that's how it works. All these things are done by basically pumps. Electrical pumps are generally used because that allows you to control the cutting power, because you really don't want to waste electricity. If let's say you are cutting aluminum, you don't want to be as high pressure that is that can cut through steel. You are wasting energy. So we want some control. That is why generally electrical pumps are used. Now why do we want to use basically water jet cutter? We already looked about CNC mill, we already looked about laser cutter, we already looked about plasma cutter. Why the heck we want to use water as a cutting material? Well, there are many materials that simply do not like thermal stresses. There are very specific metal alloys, they really don't like to be heated, and there are some other aspects for aesthetic reason. Let's say you want to make a countertop for a high-end luxury home, and you want to cut a water sinkhole. Awesome, no problem. But if you did that with a basically laser, that whole area would be scorched. and nobody likes that. Like if they are paying you, $1 million or something like that for their home, they don't want a scorched, countertop. For that reason, many things don't like thermal stress. And there are other reasons also, because if let's say you have thin material, it could warp. Even with laser power, it could just warp, because even though you are cutting it like say in a very specific place, once you go long enough heat would have seeped into it, it will warp the material. So there are many reasons for that. Like even for thin materials, people use water jet. On top of that, it's not a fire hazard, so you can understand that plasma cutters have a habit of setting almost anything on fire. So fire hazard is, again, it's not a big deal, because anybody who's dealing with plasma cutters generally are smart enough to handle that. But again, it's just a reduced insurance cost. Now it can cut through anything. Now this is the main reason, this is the bread and butter of basically a water cutter. Because let's say you want to cut carbon fiber, again you can use a laser, but problem is, because of the carbon's nature, inherently it's a quote unquote carbon and black, it will react very strongly to laser, so you will have heating damage. You may want to use plasma, but yes, the plasma will not work on non-conductive materials. So flat out, the only option you have, either use CNC mill, which will grind it up and eventually heat it up, or just use water cutter. So that is why it can generally is classified as it can cut through almost anything, and it to a very high thickness. It does not suffer from the same limitations as laser cutters. Like laser cutters, you have to have 10 kilowatt laser output before you can reach a point where you're like, yeah, I can cut through 1 inch thick material. This puppy, they can cut as thick as like 1 foot to 3 foot. Like they are very powerful basically. So that is why people use water cutters. No thermal stress, low fire damage, and it can cut through anything, and it's very cheap. The whole machine is so cheap that I have provided a YouTube video link down below, that you can see people have built it in their home. So it's not something that is like you have to have PhD to build it. It's something doable. Now, what are the benefit of doing this? Let's say you bought the machine. What are the benefit that you are getting? Well, first, it can cut soft material. Now you might be like, okay, shouldn't cutting soft material would be easy task? Well, you have to understand it this way. Let's say you have foam. You use laser on it. That's a fire hazard. You can't use plasma. And if you use CNC mill or saw, which were used in earlier days, the problem is the cut quality will not be very nice, because every time saw is doing like this, saw and all that, it will tear apart the fibers. So you will not get a clean cut. So we generally use water cutter. Like you can get, like it's a very precise cut. So for that reasons, you can cut through. Like if you want to cut rubber, you want to cut textile, or you want to use it on meat industry. Meat industry also uses water cutters and all that. So that is a very critical advantage. Like in software, if you want to make sure you are cutting something soft, something squishy and all that, water cutter is like, I got this. So that is one very critical advantage. Then it can cut non-conductive material, because in terms of cutting force, plasma is very powerful, but it cannot touch stone, granite, or anything like that. So flat out right there, like many custom industries will be like, yeah dude, I can't do anything with this. So let's say you're making tiles or marble statues and all that, you can't use plasma and all that. So that is another aspect. On top of that, it can handle uneven surfaces. Anybody who's dealing with laser will tell you first thing, laser focus is a very critical thing. So we generally keep laser as a beam, like till the last point. The moment we reach the final nozzle, quote unquote laser nozzle and all that, then we have the focuser. Now that focuser focuses on a point. Awesome, that point you get perfect cutting. But if that point is off by even as little as 1 centimeter, your cutting will be gibberish at that point. Again, it's not that it's not going to cut, it's just instead of getting a clean cut, you're going to get a splotchy blob, or you may even cause thermal melting in that place. So you can understand lasers are very intolerant of surface finish. So you have to give them flat material, otherwise they will be like no. And the same goes with plasma is a bit more forgiving, but it's still not something where you can have a lot of uneven surface. Water cutter simply does not care. It's like you put it bowling ball is like, I got this. You put whatever you put in there is like, I can take care of this. So that is a very comfortable advantage. Let's say you're dealing with a lot of stones and quarry and all that, you don't have to spend time processing it. Now all those things, those are good add-ons. Those are that's good enough. The final nail in the coffin, the final reason why so many people use it, even in metal industry where they can use plasma cutter, is the edge quality. Because while laser does give better edge quality, it's ludicrously expensive. It's so expensive that only right now, as I'm speaking to you, the best result I can say, there is barely 500 to 600 laser cutter that can reach 10 kilowatt power output. So you can understand that. And lasers have the best edge quality, and plasma has a horrible. So plasma's horribility simply means you have to spend time, like you cut your material, you have to spend time grinding it, polishing the edge, so you can send it to the welding phase. Here you will get very clean edge cut. Now if you are buying from a reputable manufacturer, any reliable sources and all that, they will give you something like this. So this is generally card defining what kind of cut quality you can get: Q1, Q2, Q3, Q4, Q5. And it's similar to like grit. Basically the smaller the number, basically the bigger the number, the more polished output you will get. So at Q1 is still better than plasma. At Q3 it's like you can literally run your finger through it and you won't even feel it. At Q5 it's like it's at that point it's same as laser thickness. So you can literally cut a part, metal part, and you don't have to grind it. You can just directly send it to welding parts. So that is a very critical time saving, and it is more or less same cost as plasma. So that flat out is the primary reason why so many people use it. First, you can deal with soft material, you can deal with uneven material, and if you are cutting metals, you can get a very high quality cut surface out of this. So these are the reason why people like the system. So, okay, if people like it, there must be some side effects to this. Well, absolutely. First, it's very expensive. Now, again, you might be like, didn't I just say a few seconds ago it's cheap? Well, the machine is cheap, but the running cost is high. That is a critical aspect with this. Plasma has electrical cost, lasers have electrical cost, but that's kind of it. That's like, yeah, that's your primary concern. You will have gas consumption, you will have some cooling system and all that. Those will be like, secondary. You will not worry too much about it because your primary will be like, big chunk of it. Now, here it's completely different. Not only you have to worry about water, not only you have to worry about basically electricity. Those two things you are consuming liberally. On top of that, you have to worry about coarse abrasive. Basically, this abrasive cannot be recycled. I used to think like you can just filter it out of the water and recirculate it, because it's going through the material, like you are grinding it. It is also getting grinded away, so it is also becoming smooth. So you the moment you get the clean bag, it will be like very coarse. After it's run through the machine just once, it will become like a soft sand. So you have to understand that like any place where they are cutting continuously, they will have like truckload of these as a consumable. So that it does increase cost. It increases cost to such a point that any laser cutting machine, they will flat out say per inch cutting cost. Basically like, hey, are you cutting 1 inch thick steel? They will say like, yeah, $1 per inch. So yeah, it is very expensive. That is the reason why you don't see it everywhere. Even if people have to have grinding stage, for many people that is acceptable compared to bags and bags and bags and trucks and of basically abrasive that they have to spend. So it is not something that is like you buy and forget. It's not like laser just electricity bill or plasma or something like that. It does have tangible running cost. So this is the primary reason. On top of that, it's kind of messy. Now lasers is the best cleanest because it does not make too much noise, it does not create too much spark, and with a fume extractor you good. That's the best advantage. Plasma, it's a fire hazard and it's very noisy and sparkly and electrically also noisy. So electrical equipments around it will not work very effectively. Now this also has another aspect. It's electrically, it does not care too much. However, it does have water. On top of that, it's just not that water like, okay, you have water splashing around and it will evaporate over time. That's not gonna happen because it has sludge in it. Basically the material you grind it away plus the aggregate I'm saying the abrasive. So you can understand it's like muddy is saying any place where you can see this, generally that area will require too much cleaning to maintain. Again, you may not care about it, but again, it's something that you have to worry about, because let's say you have a factory floor and you have 5-6 of machines, these machines are running around. You have to double check it basically, because let's say workers are running around and because of the water the floor becomes slippery. That's a dangerous workplace. So it is something that you have to worry about. The primary oopsie is like the cost of basically cut per inch. That is like the primary whoops. And another aspect is just it's messy. It's not as clean as you would think. The output is clean, but the work machine is ugly, so to say. So this was my brief overview about the Waterjet cutter. I hope you liked it, learn from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.